Hello everyone, for this tutorial video, I would like to show how to find the sector of a sphere, which, by both its strict mathematical definition as well as what you can visually estimate, is essentially the same exact thing as the sector of a circle, as the sphere is the most closest 3D shape to the circle, compared to something like a cylinder or a cone. To get a sector of a sphere, you would cut the shape so that two radii meet at a common point, and the common point is opposite to a curved surface, which is exactly what we did for a circle in 2D. We will see, because this method is the same, the resulting formula will be the same, except the volume and surface area of a sphere are different than the area and perimeter of a circle, which we must also take into account. So as a result, the sector formulas will be different as well. Using an example we already know from the previous video, the hemisphere or half sphere, it should be already obvious that the hemisphere is a sphere divided into two, so as a result the volume will be half as well. Extrapolating on this idea further, we would see that a sphere is rotated 360 degrees left and right and 360 degrees up and down at the same time, while a hemisphere would be 180 degrees. Therefore, we can state that the volume of a sector of a sphere would be degree out of 360 times 4/3 pi r cubed, with a caveat being, besides the volume being different than the area of a circle, the degree in a sphere now referring to 2 degrees at the same time. So the degree of a sector could be any of those 2 degrees and still work. For example, you could slice a hemisphere in half in the up and down direction like this, or you could slice it in half in the left and right direction like this, and the volume of the resultant hemisphere would still be the same, as well as the surface area. Since we have figured out the volume of a sphere sector, we should be able to guess that the surface area would follow the same pattern, i.e., that the surface area of the hemisphere would be 180 divided by 360 times 4 pi r squared plus the flat circle that constitutes the sliced area. So it should follow that if we instead cut it into quarters, the surface area would be 90 divided by 360 times 4 pi r squared, plus the area of two flat sides now, as the slices are in different directions, and so would therefore have to make different areas. Now that we have figured out the sector of a sphere, we can move on to the segment of a sphere next, which can be seen as the sector of a sphere minus a triangle, which will be the most obvious when we investigate hemispheres or quarters, which we already know. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.